All right, ladies and gentlemen, we are going to be talking about balancing chemical equations. You have some Cornell notes that look like this. Remember, it is your responsibility to be filling in all of the blanks. Um, you have your questions and main idea over here to the left. And then our essential question is, how do you check for balancing equations? So we've been talking about chemical formulas in class. We're counting elements and we're counting the number of atoms. And so we're just going to take it a step further and look at the types of equations that will lead us to chemical reactions, which is our next unit. All right, ladies and gentlemen, let's start with our first essential question. First main idea question. What is a chemical equation? So to the right it says that a chemical equation describes a chemical change. And we've talked about chemical changes already. Chemical changes are basically the ones that you can't undo, like your stomach acid breaking down your food. Alright, so you're also asked to write the parts of an equation. Now watch this, guys. This is an equation. So in your notes, it asks you to write down the parts. So you need to write down that whole thing that I just circled. With an exception. You know this is a coefficient, okay? And you know that this is supposed to be a subscript. You're never going to have a coefficient in between two elements. So when you write this down, make sure you make that a small 2, as well as this one and this one. Your coefficients will always be to the front of the formula. So this is one formula. If you notice, I'm boxing them. This is another. This is another. And this is another. So equation basically is made up of several formulas that we add together and they go through some type of reaction. So pause here if you need to finish writing this equation, unless you're awesome and you already did it. Our next main idea question is, what are reactants? Okay, so the reactant is the chemicals that you start with before the reaction. And it says it's written on the left side of the equation. Okay, so that's the same example that you see from earlier. Okay, this right here, this is our reactant side. If you notice now, my equation is right. This is now a subscript. Okay, so always pay attention to that. Sometimes in worksheets and stuff, sometimes there's typos like that, and you want to make sure you're looking to make sure those are actually subscripts. And remember, your subscripts tell you the number of atoms, and your large numbers, the coefficients, tell you the number of molecules. So I have 2 molecules of Ag, 2 atoms of hydrogen, and 1 atom of sulfur in my reactant side. My next main idea question is, what are products? Okay, so the product is the chemicals formed by the reaction, and these are located on the right side of the equation. So that's this side here, and notice my subscripts are correct again. I'm going to box these formulas. The plus sign is what separates each formula from the next, but I have 2 formulas here on the product side. So let's think here for just a second how I said that the reactants are the chemicals you start with, the products are the chemicals that you end with. Think about the process of baking a cake. Okay, let's say this is my cake. Okay, I would have to mix all of my ingredients together. So I've got my box of cake mix, I've got my eggs, I've got my milk, some people do oil, and let's say I'm stirring it all together up in this bowl. Okay, that's like the reactants. Those are the ingredients. Okay, so you need some ingredients or some chemicals to start off the process of your reaction. Now, once I put those mixed ingredients into the pan, put in the oven, I'm going to get my product. So think about the process of going into the oven as this arrow. The arrow stands for your yield. So really you read this as reactant yields product. Yield means you're going to get something in the end, okay? Your product, when you make a cake, is going to be a completely baked, delicious cake. And hopefully your cake looks a lot better than my little drawing here. Okay, so once I mix together the ingredients, that's my reactant, that's the left side, I'm going to yield a product, which is my final thing after they go through the process of some type of reaction, whether it be adding heat or just mixing things together. All right, let's talk about our examples of a chemical reaction. This is question number 4. Let's rewrite this equation correctly. So it should be 2H2 plus O2 yields 2H2O. Okay, so I need to note that I have a reactant side. This is my yield and this is my product. Okay, so these are my ingredients. I mixed them together to come up with this 2H2O. Make sure you write that example down next to number 4. Okay, next we have the law of conservation of mass. This is number 5. This is very, very important. This is pretty much what they're going to test you over in relation to this. Okay, so in a chemical reaction, matter or mass is neither created or destroyed. In other words, the number and types of atoms going into the reaction must be the same as the number of atoms coming out. If an equation obeys the law of conservation, it is balanced. And that's all we're going to be checking for. When we look at these, we're going to count the number of atoms on the left side and make sure it matches the number of atoms on the right side. That's it. Alright, now we have to write down our examples, and up here it says to write down 2, so make sure that you write those down. Alright, this is going to be an unbalanced equation, and let me show you how. Okay, I've got CH4, that's my first formula, plus O2. There should be a yield here. There's my arrow. That yields a product of CO2 plus H2O. Alright, so this is a pictorial example. Remember when we were using the colored circles to demonstrate this? So here's on my reactant side, I have CH4. So I obviously have 4 atoms of hydrogen, that's the green, and then 1 atom of carbon. Plus O2, so I have 2 reds that represent oxygen. So I have 1 carbon, 4 hydrogen, 2 oxygen atoms. This bar here is going to be my yield, and on the product side I have CO2 plus H2O, and all I'm doing is counting the number of atoms of elements on each side. So if you notice here, I have 4 green, I have 1 gray, and I have 2 red. Okay, on this side I have 2 green, I have 1 gray, and then I have 3 red. Those numbers don't match. I have 4 green on this side, but I have 2 green on that side. As long as I find one element that isn't balanced on both sides, the whole thing is unbalanced. Everything else could be unbalanced. Everything else could be balanced, excuse me. But it only takes one to make the whole thing unbalanced. So since this is unbalanced, it does not follow the law of conservation of mass. Alright, here's our second equation. It is a balanced equation, so we're going to see how this one is different. Alright, let's look at this. I have my formulas. Okay, CH4, I have 2O2, and then there's my yield. They keep forgetting to put it on there. Then I have CO2 and 2H2O on the product. Okay, so here is CH4. And then I have 2 molecules of O2. Okay, that's my reactant side. Here's my yield. Okay, and then on the product side, I have CO2 and I have 2 molecules of water. All we have to do is count and make sure I have the same number of atoms of each type of element on both sides. So I see 4 green on this side, 1, 2, 3, 4 green on that side. That checks out. I have 1 gray with 1 gray. I have 1, 2, 3, 4 red with 1, 2, 3, 4 red. That means this is balanced and it does follow the law of conservation of mass. And that's pretty much it, guys. Make sure you've completed all of your notes. Make sure everything on here is checked out. Okay? down here at the bottom where your example, that should be your 2 examples. Right here should be here. Okay? And make sure you answered all your Edpuzzle questions. Ta-ta!